All right, here's 10 2-day one. Of the same 3 days as we did in the first section, we're just turning our attention over to means. Okay, so no 4 steps today. We'll get in the next couple days. We'll get to intervals and significance tests. But here's just kind of the ins and outs of means. We're kind of building up on this one to get to a normal CDF. So talk shape, center, spread. So for the normal condition, notice both sample sizes they took for these potato manufacturers, Riderwood and Kimberly. They're both less than 30, but it did say in there that both populations are known to be normal. And if that's the case with means, you can use whatever sample size you want. Right? Sometimes it's easy to lose sight of that because you think of the rule that you can use the normal curve if your sample size is at least 30. That's technically, that only comes into play if your population is not known to be normal or is known to be non-normal. Said the two means were 180 minus 175. So my normal curve should be centered at 5 grams, which would tell me that typically I would expect that the Kimberly potatoes, if I took 2 samples of 20, I should get an average weight for each potato of about 5 grams bigger for the Kimberly than the Riderwood. New formula here for standard deviation. You have sigma 1 squared over sample size 1 plus sigma 2 squared over sample size 2. Both sample sizes are 20. For the Kimberly potatoes, sigma is 30. And then for Riderwood, it's 25. And that would be 8.73 grams. All right, really low on space here. I took up way too much for part A. I need room for a normal. A normal curve, but we can fit it in. We can do it. Here's our normal curve. We said this was centered around 5 with a standard deviation of 8.73. So the probability of the mean weight of the Riderwood sample is larger than the mean weight of the Kimberly sample. Okay, 0 would be over here, and that splits up the normal curve into 2 sides. Okay, the much bigger side would be if the Kimberly sample is bigger. That's what we'd expect because it, typically produces potatoes that are slightly bigger. We're expecting something in the ballpark of that sample on average to have potatoes that are 5 grams heavier. Here would be the other side. That over there would represent the Riderwood samples. being bigger, which doesn't look as likely, but certainly could happen. And the likelihood that it happens would be the p-value that we would get from a normal CDF. And it would be 0.283. So to answer their question, should they be surprised if this happens? Well, no, and our reasoning would be, you could go a couple different ways with this, right? 0.283 is a large p-value. That this outcome they're talking about is not all that uncommon. Really gets back to the fact that it's bigger than alpha, so we're going to say it's an outcome that's not all that unlikely. All right, new context here, same idea though. We're building towards a normal CDF, okay? So you've got these two different settings that are filling soft drinks at a restaurant. The large should be 27. I think it says the medium or the small. Yeah, medium is the 17. Okay, so the first two parts are again kind of taking us through. Are we sure we can use a normal distribution? Where is it going to be centered? What's going to be our standard deviation, right? Before we go do a probability calculation, we got to be okay with all that. As far as the shape goes, as you would expect, normal, except now you have a sample of 20 and a sample of 25, but the reasoning is the same. Both populations are known to be normal. And that's all we need. The mean, as far as the difference, if I were to do these particular sample sizes, our normal curve should be centered around 10 ounces if the two settings are functioning properly. Right? We should see a difference of about 10 ounces. And then with sigma, standard deviation for the large setting is 0.8, and that was taken from a sample of 20. Standard deviation for the medium setting is 0.5. And there we took a sample of 25. Okay. Find the probability that there is more, that the difference is more than 10.6 ounces. There's our normal curve, centered at 10. The standard deviation of 0.205. 10.6 would be like right here. And again, we're looking for a p-value from the normal CDF that would be right up here. You go do a normal CDF with that, and you would get 0.0014. 0.17 would be the probability that we would see that. Worth noting, our normal curve does assume that the two settings are functioning properly, right? That they're going to 17 and 27, giving us a difference of 10. So for question number 4, I'd say yes. I would be surprised there's only a 0.0017 chance of this happening. Now it's worth noting the reason I said yes is I thought of my common alpha values like 0.1, 0.05, and 0.01, and this p-value is below all of them. So as far as the outcome described in number 3, we would say that it's rare. You know, you could easily think of this in the form of a significance test, though, that if you observe this data, it would lead you to believe that the settings aren't functioning properly, right? You're getting a difference that's too big. If they were both functioning as they should, we should get a difference of about 10. Then it's good. If they were functioning properly and we just got a weird sample with a little variability, that's possible. But again, the p-value takes care of that, and it's not that likely. It's just due to chance.